Hello everyone, so in this video, let us talk about interfaces. In my initial days, I used to struggle a lot with interfaces in my initial days of my college as well as in my organization I used to work because I don't understand why it is used for, actually why we just have to define the method signatures and why it is all together used. But as with time, I understand the actual usage. And I will give you a lot of examples throughout this whole lecture. We have divided interfaces in two videos. This is some sort of an introductory part. We'll go through a lot of two examples as well and different examples as well. Uh, and we'll understand in depth about interfaces. And the next one we'll go to a little bit more deeper. So let's talk about what all are interfaces. And I hope that after this video, you will get a very good understanding with examples of what interfaces are and where it is actually used. So we'll first go over definition. It might not sound intuitive to you at first, but we'll take some example and revisit it. So as you can see, an interface is a type that specify a set of method signature. So it's a type in Golang. It's a type that specifies method signatures. Okay, so you have signature like what is the function, input, and output. If you just define those inside a type, that is called interface. Okay. Now you might be thinking, okay, you just define the method input and output. What that actually means. Now another thing is that it's like a contract. This is like a contract. Interface is like a contract which says if you have these methods, then you are my type. Which means that if you have certain methods, if you implement that, then you are of my type. These are the things actually defines interfaces, but doesn't sound intuitive to you right now. Let's take a very good example, which I actually thought of and write the code of it here as well. Let's take an example that you have your production level code, something like that. You have all that code written here. And in that code part, you have to implement a caching mechanism. You have a cache. Now, there are different providers for cache. Let's say there's Redis, there is Memcache, there are multiple more. Let's take these two examples. So, we'll not go into details of what caching mechanisms are, what cache is, but let's say that we have a certain provider that provides us a caching mechanism, and that are two providers, Redis and Memcache. Okay, our code internally uses cache and stores some response. Now, if let's say both of these caching providers has the same logic, okay, cache is some sort of, you can say, a key value pair, okay, for a fast retrieval. Okay, you have a key, for a key you get a value. Both the internal things is same, but just the providers are different. Like both of them are different providers. Let's say now you're currently using Redis. Now tomorrow your manager asks you to move from Redis to Memcache. Now what you'll do? Whether you'll change in the whole code wherever Redis is used, you move to Memcache, or you should have already designed your code in such a way that you can directly just move from Redis to Memcache because the implementation is same. The logic of the code remains same. Just the provider changes. Only one of the things change. Now, so what you could have done in this scenario, you could have used interfaces. Instead of writing down methods, instead of writing down functions specifically for Redis, you could have exposed an interface on top of this caching mechanism such that whenever you want to move from one provider to next provider, or from maybe from one struct to another struct, you can directly just go and the other internal parts remain same because you have just changed the provider because you are using interface. One more example which we generally used in when we are talking about interfaces in my college days is a remote control. So what a remote control is, when you're using a remote control to, let's say, use a TV, when you're so what actually happens is in a remote control you are given some buttons. So these buttons you can assume as function or methods. Okay, you do not know what is happening inside. Okay, so you only are exposed to certain functions. So let's say now you buy one more remote. If both of the remotes may be of different companies, but if they have the same buttons, let's say this also have one, this also have one, this have two, this have two. All of the buttons which are here are also here, and they both work on the, let's say, same maybe frequency, radio frequency, or like not radio, infrared frequency they work upon. then they both actually are same. Maybe the internals might be different, which you are not aware of because you don't actually care about the internals. You just have to use the remote. That's the whole thing here as well. That whatever internal, whoever has made the remote, whatever internally they are going through, whatever circuit they have, you don't care about that. You just only have to care about the buttons you are given to. So this actual remote is actually interface. So you are given these buttons. You only have to play with these buttons. So that is what you have to expose methods from red, like these caching mechanisms, and the internal code should only work with those methods. Okay. Now you don't actually have to care about the internals. The internals is maybe handled by Redis or Memcache, but the actual code should not know whether it is from Redis or Memcache. That is why you have to write down an interface on top of it. That interface will expose some methods, and you only have to allow to play with those methods. Now the methods have to also be implemented, like whoever has, like the internals have to, you also have to write, but the actual function calls, whichever are doing it, will only care about these final methods which they have to call using the interface. You don't have to actually understand wherever these methods are attached to or wherever these methods are calling from. It only depends upon the starting company or so on. I hope you understand a very overview, high overview of what interfaces are. Interfaces is just some sort of a method definitions. The internal code only call those methods provided by the interface. Now the interface has the actual thing that whenever you initialize the interface, not actually initialize, whenever you initialize a, let's say, provider or a struct, whoever implement all the methods of the interface will be actually used to call that. That's the overall logic of what interfaces are. Don't worry, go through a lot of examples as well. So let's take this example, which I've used the same thing of Memcache and Redis, and let's talk about that. Where's this code here? Move these parts out. Okay, so what you can see here is there is a interface called cache. So now we have an interface called cache which only has methods, and those method definitions, the what actually the method definition you don't care about, you just have these methods. Okay, as you can see that it has only a method connect. Now your different structs mean, like, let's say providers. You have a memcache provider, you have Redis providers. Now you might be thinking like how these providers struct. By struct means like what is the definition? Let's say this memcache has some username. Okay, you have some username, or maybe you have a password. Okay, all of those, and then URI. So all of this is provided by memcache configuration. Let's say at what point is your memcache, like you can say storage hosted and all of that. You can store it here, but it just means that you have a provider here. The username, password, all of that is stored in this struct. I'm not actually using it right now, so I'm just making it empty. Now what you can see here is that in the main function, both of these providers are now implementing the connect. So as you can see, this is the receiver. The receiver is of the type for this particular method, the receivers, both of these have the same like method name, but the receivers are different. One has a Redis receiver and other is Memcache receiver, and both just tell that okay, they are, if I use and if I initialize a cache with a Redis receiver, what you can see here is that this cache has now a method of connect. Now see, I am calling cache.connect. I'm not calling redis.connect or memcache.connect. In the whole code, I'm now using cache.connect because I'm connected to the cache. But this doesn't know what type of provider I have, because I can use it throughout my whole code. I can use multiple more methods. But what you are trying to say is that I'm not using Redis or it. In the initial state, whenever this whole code starts, I'll just start and change. I'm selling that this is my provider. My provider is Redis, and all the other code I'm not saying whether it is Redis or not. So what you can see here is now that actual benefit part is that now it will automatically understand that this is Redis. So I will call Redis connector, and it will print Pong from Redis. So it will automatically understand that I'm providing an instance of Redis. So that is why it will understand that this is the receiver and call this function instead of this. So that is what the actual benefit is, that you don't actually have to like in the internal of the code, you just have to provide this interface. Now, whenever I want to connect to let's say, uh, Redis provider or like caching provider, I just have to call this connect function. They don't actually have to understand like where this is actually called from. They actually just have to call the connect function. And that is what interface is. You don't actually care about what is the internal, you just have to call the actual function calls. Now, if I directly just change this from memcache, it actually just now call form from memcache. Between simple. That's one of the things. So the actual benefit, I hope you understand using the example as well. So what is the importance of interfaces? It helps you to achieve polymorphism. Polymorphism means that one of the key reasons for polymorphism in like this is one of the reasons why actually interfaces is used. In Go, polymorphism allows you to write code that can work with objects of various types. Okay. So as you can see, both of these methods has the same name. Both of them has the name connect, but both of them work differently with different receivers. That is what actually polymorphism is, as long as they satisfy a certain interface. They both satisfy the certain interface. How they satisfy certain interface? Because both of these providers or like six structs, like as you can say, has all the methods implemented from this interface. So what now you come down to the first definition, that if you have my methods, then you are my type. So which means that because now Redis implements all the methods provided by the cache interface, Redis is now typically a cache type. Okay. Similarly, both of them are cache type because both of them implementing the methods of cache interface. If there are multiple more methods and if they don't implement that, then they are actually not of cache type. All the functions have to be implemented, all the interfaces methods have to be implemented. Then it is only of cache type. That is one more thing. So I hope you understand what is you can read about polymorphism as well. So polymorphism in simple terms, you can say that you just have to so polymorphism in simple terms, as you can see here, is like you have a set of methods and set of methods and different structs like different structs or different objects can implement that. Okay, and like if they satisfy a certain interface, then that is called polymorphism. So as you can see, this enable us to write more flexible and reusable code, okay, than polymorphism. So you can read it online as well. It's very simple definition. But I'm talking about interfaces here. Now let us talk about, let me break it down a little bit more. With polymorphism, you can write functions or method that can accept interfaces as parameters. That is also one more good important, that in polymorphism, as I've told you, you can write down functions or methods that can accept interfaces as parameters, because now you are actually passing the methods. You don't actually have to provide the pass the like the provider. Like you can say that like this Redis or Memcache. You just have to pass the methods. If they actually follows those methods, you can call those methods directly. These parameters or functions can then work with any type that implement that interface, providing a high level of abstraction. Now, a high level abstraction, you don't actually know what is like the provider is. The actual code, the actual logic doesn't know the provider. They just have to implement those methods and their task is done. Let's take this as an example. It will become more clear to you. Okay, so it's some sort of same thing. As you can see, we have the Redis struct, the connect function from the cache interface, the same thing. What we have done is that we have created two. So now what we have done is that we have created one more function. Now in the parameters, it is of cache type. As you can see, it is of that interface type. And because of interface type, this is a cache type. But you can say I can directly just call c.connect. See, I in this, so let's just see over just don't think over the other code. Just see over this function. Does this function know what is the different type of caching mechanisms I have? It just takes a cache as an interface as an input. And because cache implements this method, I can directly just call this method here. So what you can see here is that now we have to just pass, if I just pass cache as here as an input, it will automatically understand that if I want to pass cache, the cache is of type like any struct is of type cache if they implement all the methods provided by cache. So as you can see, this can be called with the Redis instance or like the Redis object as well as memcache object. Why? Because both of them are of type cache, because both of them implements all the methods provided by the cache interface, which is this and this. If let's say I just remove this part, let's say memcache doesn't write down all the definitions provided by the cache interface. So which means that that is not of cache type. So I cannot put it of cache type. That is why it starts giving error, because memcache is not actually written down, because I'm passing memcache as a type cache, but it is not of type cache because it doesn't actually write down the definition of connect, because it has to be written on the connect function, because then it is only of type cache. That is what it is giving error. And if I just bring it back, it's solved. So as you can see, like both of, so I'm calling a function directly. This function doesn't know. This function doesn't know. So that's why I can write down functions in the whole code, which actually doesn't know the provider. We can just directly mention methods. So let's say that is why we don't actually care about the providers. We just have to care about the input and the output. Whatever happens inside the method, whatever happens inside the function, we just have to care about the input and the output and do all these variables, call all these functions and so on. Whatever these functions are there, they have to be implemented by their, as you can say, receivers or provider, what you can say, and then they actually call them, because whatever you initialize them, pass them, depending on that only these things are called. That is what the interface is all about. I hope you understand a great overview of what interfaces are, because it is called here. Like both of these are calling this function, depending on whatever their actual, you can say, struct is, they're printing it out. That's the overall idea of what interfaces is. If you still have any doubts, you can mention it in the comment box for this particular video. I will see you in the next one with more such videos. Till then, take care and bye.